All right, I want to work this example because we approach it a little bit different than the other ones. Got two couples, 300 and 300 and 150 and 150, and they're parallel and opposite. But the problem is we don't have the nice simple perpendicular distance. And we could do a little trig and get it, but there's an easier way. And we'll do that by resolving each force into its x and y parts. Okay. So if you look at the 300 pound, the x parts are going to point along the line of action of both of them is the same, so there's zero distance, so they don't cause a moment. In other words, they can't rotate about the point that you're trying to rotate around. And so the only part we have is the vertical part, which in this case would be 4/5 of 300. Perpendicular distance between those two lines is our 2 feet. Now, the hardest part sometimes is to get the sense of rotation. So if I pull up here and move around like that so I can rotate about the center here, then that was going to be what? Clockwise? So that's going to be negative. The same thing here. We've got a 150. We've resolved x and y. This time the y's point through each other, so zero moment arm. So we're just going to have 150 cosine times the 2 foot distance, which is times the perpendicular distance, which is 2. And again, we're pushing this will rotate around the center, so it would have to rotate around the center. I think of a point in the middle, and I'm going to rotate around it, and that would also be clockwise, so that one's also negative. And so I'll go back. And so that means we add that up and we get minus 739.8 feet. Now here's one, a 3D one, and we can do a straight R cross F, or we can do just a little geometry to figure it out. But they make a plane. There's your two F's. They make a plane. If we do the R cross F, then I'm going to use this F and the R from A to B. And so I got to write my A to B, and I get, because of what he's given me here, let's see, I know what A is. It's 0.3 in the X. Well, no, this RAB is just 0.4 in the X direction. So that's our R. Our F, we've got to break up into, it will have a Y part and a Z part, and the Y part will be minus 4/5. Well, if I'm doing B, it'll be plus 4/5, and the Y part and the Z part will be minus 3/5. So I have and then I can do R cross F, and when I do that, I get 108. Remember, cross out row and column. So you get I minus JK, row and column, you get 0 times 270, 0 times 360, row and column, 0.4 times a minus 270, 0 times 0, and cross out row and column, 0.4 times row and column, 0.4 times 360 minus 0 times 0, and that's what I get when I do those numbers. And so that's a moment perpendicular to that plane. Here's another one where we have him in 3D. They're already given as couples. Well, no, they're not. No, they're not. They're given here as forces. And so we'll have to write the vectors. And the way he's given it to us, again, we've already got the perpendicular distance, 0.3 times 125 and 0.4 times 150. Again, perpendicular to the plane containing the forces. So that one's going to be, with your hand rule, in the plus X direction. That one's going to be at an angle, but he gave us perpendicular, and he already gave us the 3/5. So we can write those as vectors and then add them up and have a single moment. I don't know if I did the numbers here. Yeah. Replace the two couples by a resultant couple. I didn't show all the arithmetic on that one, but you can do your M2 is going to be all M1 is all in the X, and those are both in the Z and Y, and then you can add those up, and then so you've got all three components, and then you can do, well, that's M1. That's M1. He did do the arithmetic. We get a 60I, and that's M2, and he did an R cross. So he got an M2, and then he added them up to get the M3. I'll post some examples of some problems that I worked, and it should say 4-6 as in that show. And so let's go. Let me get that changed. Yeah, section 4-6 work problems. And I've worked several homework problems there. Couples are important, and we'll use them later in the next several chapters. So if you have any questions, shoot me an email.